On April 16, 2023, an Embry-Riddle capstone team, Cygnus Suborbitals, launched Deneb, breaking 3 world records, achieving the highest altitude of any amateur, undergraduate, or collegiate liquid rocket. The following year, the Mountain Spirit program of the Rocket Development Lab, a club at Embry-Riddle's Prescott campus, assembled a team of undergraduate engineers in hopes of building a successor to Deneb. And on March 16th of 2025, the culmination of thousands of hours of research, sweat, and dedication was brought to the launch pad in the Mojave Desert.
8, 7, 6, 5, 2, 1.
My name is Holt. I was the fluids responsible engineer and flight controller for Deneb 2 Electric Boogaloo, and I was a junior when I started the project.
My name is Quentin Trulll. I was the recovery responsible engineer for Deneb 2. And at the time of the project starting, I was a freshman.
I'm McKenzie Kelly. I'm currently a junior. I was a freshman when I was first on the project. And I was the manufacturing responsible engineer, as well as I was a test team member.
My name is Olivia Wood. I was the team lead for Deneb 2 Electric Boogaloo, or D2EB, and I was a junior.
My name is Billy Temple, and I was the composites and structures engineer for Deneb 2. And I started about a year before we launched, so it would have been towards the end of my sophomore year.
I'm Scandrett. I was a data acquisition and control responsible engineer, as well as the vehicle test controller. Would have been junior when we actually officially started the project.
My name is Henry Johnson. I was a freshman when I joined the project, and I held the roles of helping a lot with the recovery hardware integration, a lot of the stuff at FAR.
The Mountain Spirit program as a whole is kind of what inspired it. So like our goal is to reach space with a liquid rocket. So that was the origin.
We had 2 rockets before this, Altair, and then it had an anomaly on the pad, which was followed up by Deneb, the original.
So before Deneb 2, there was the Deneb 1 flight vehicle, which was a fantastic project.
The capstone in 2023 launched a record-breaking vehicle.
But we didn't succeed with everything that we wanted to with our Block 2 rocket, which was Deneb 1.
Deneb 2 has kind of birthed out of that to address those issues, fix them, and maybe just give that project more time.
When Deneb 1 launched, it underperformed by about 50% of its target altitude. And so the idea with Deneb 2 is to take all of our learnings from Deneb 1, refine the vehicle, remove those inefficiencies that we saw, and then launch a sister vehicle to Deneb 1.
Put it together and started talking about it, started grabbing people, and started putting together what this would actually look like.
And so we made Deneb 2 as like the successor rocket to try and, bridge the gap that we were hoping to bridge.
It was to fix a lot of those issues. The greatest way to learn is by trying it, and we tried it, and now let's go apply that knowledge to something else.
The goal of launching like any undergraduate or any collegiate big rocket, big liquid rocket, it's to learn, it's to grow, and it's to do really cool stuff. So for Deneb 2 specifically, the goal is to kind of do a recreation and fix a lot of the anomalies.
I think we did at least pretty well in a lot of those standpoints.
Build process was pretty intense.
Everything with that rocket was a roller coaster. Building was definitely had its ups and downs.
When you're working on optimizing a design instead of just creating something new, you can encounter kind of limitations.
Deneb 2, like I said, just a sister vehicle to Deneb 1. It was a liquid oxygen kerosene vehicle with a 1,750 pound force engine, 300 PSI chamber pressure.
Janus 4.2, which is the successor to the original Janus 4, which flew on Deneb.
The thing I was responsible for was taking the fluid system that Deneb 1 had and converting it over into what we needed for Deneb 2. There was a couple inefficiencies in the feed system that made the launch underperform.
Get Derek to help you out.
So we were working on improving those, as well as the vehicle was going to get longer overall due to an updated recovery system.
Deneb 1 had a lot of structural issues with the recovery system. It had a high-speed deployment, so we designed the Deneb 2 recovery system around being able to survive a high-speed deployment. So we had really strong shock cord and a kind of unique ab bay design. We also switched to a dual compartment, dual deploy system instead of having a single step dual deploy, just to increase the reliability.
I did a lot of the work with the composites, so the fin can, you can see the tail cone. And then the fiberglass windows, the raceway. I worked a lot with the interface between our tanks and our upper system.
It had a very similar overall vehicle architecture with a kerosene tank on the bottom, liquid oxygen tank in the middle, and a nitrogen COPV up at the top.
Tank manufacture was a big thing. That was the first thing I did as a freshman. So tank domes, tank structure, working with the machinists on campus, getting it welded, but also machining the end caps, machining the bodies of the tanks, the aero structure, the thrust structure, stuff like that.
When you're trying to optimize that, you're trying to reduce the amount of free space.
And then also the large carbon fiber tube at the top, that was all my team. And so it contributed to a significant portion of the appearance of the rocket, at least.
The first big thing I did with the rocket, one of the first things I did with the rocket was to just sand for hours and hours and hours and hours.
I guess the tube on its own, I mean, it's such a large tube and our filament winder can't wind that large, and so it gave us a lot of problems, so we had to discover new methods of manufacturing.
We had like a 130-pound or 160-pound dry mass vehicle and 320-pound wet mass. So we over doubled our mass with prop on board.
And then I moved into more of a general role, helping out Miles, our fluids lead, with a lot of the fluid system stuff, and then working a lot on test team through our large test campaign.
My favorite part of this whole campaign of Deneb was definitely testing.
Deneb 2 went through a full vehicle testing campaign.
Deneb 2 underwent so much testing. We tested every component of the vehicle, both individually, subsystem-wise, and fully vehicle integrated testing.
We had to verify that every single system worked 100%. There was nothing that we kind of grandfathered in testing-wise. We had to verify that every part of this vehicle worked.
This rocket is going to be lifted up by people here on the pad.
We were out there every single week, and even some Tuesdays and Thursdays, and then those weekends. And so we were sacrificing a lot of time for this rocket, and in my opinion, it was well worth it.
We did a lot of testing to try and make sure that the chutes would come out before we actually flew the rocket. And we had a lot of failure happen in that case, specifically because the body tube that we manufactured was not perfectly concentric. So a lot of the deployment gases would escape around the gaps and wouldn't separate reliably. So we had to fix that.
But the testing kind of involved a majority of just sequencing, leak checking.
We started at just pressurant flows, leak checks, cold flows with inert propellants.
We had a really hard time making it through our cold flow tests and sequencing to get the engine into the correct config, so that way it didn't blow up when we started it up.
Then we went into sequencing of the propulsion system. We went into, our first vertical integration was so that we could do things like wireless connectivity tests.
Our campaigns were laid out as in cold flow and sequencing. So you'd sequence your injector and your main valves. And then you would go into your flamethrower test. The first test that we did with fire was a flamethrower, and it detonated. This was because we didn't do an injector chill. We didn't chill the injector enough, I don't think, leading into the test.
And so that set us back a little bit, but the team was really great. We all grouped together and went to go improve the vehicle, fix it, and get it back to an operational state.
It doesn't even feel wet. I know, that's why.
And then the hot fires that came after it, we noticed there was a lot of issues we were having with the chamber. for our rocket engine.
But we would always end up burning through.
During those long duration burns, we went through over a dozen burns of aiming for 10 seconds, either burning through or our ablatives not working out. And so a lot of our test campaign focus then moved over to ratifying or rectifying that ablatives issue.
And we're having quite a few issues refining and making it survive the whole 20-second burn duration. And that is where a lot of our testing time went, was making a chamber that can survive the hot fire.
Through a variety of testing and optimizations, all of which did increase the performance of the vehicle and the reliability of the vehicle. The ultimate problem really found to just be the material.
From that silica, and that's when we started getting into our successful tests. But then we ran into the problem where we weren't seeing the engine performance that we wanted to. So we static fired, got the 10-second static fire done, and we were like, oh, like this is awesome. We haven't burned through the chamber this time. It's huge. We all like went and celebrated afterwards. But then when we data reviewed, we were like, where is all of our thrust? Let's figure out how we're going to saturate the prop correctly, and let's run the last test. And after this test, we'll see how good it is, if we need to make any other improvements, and we can deliberate if we're going for flight. And this was November, end of November.
We have like a week before we're supposed to launch, and we're really trying to get our final numbers for ablation, burn duration, and thrust. And we're hoping this is our last burn, or our last test, because we have our flight in a week.
Nothing was wrong going up into the test. We're usually very vigilant, and we were very, very vigilant this time as well, as we normally are.
And we do everything as normal. We'd had, tens of tests up to this point. We had a lot of experience.
And it felt great. We were going to the test. It was amazing, and ignition happens.
The computer told the valve to open at the right time, but there was a problem with our pneumatic supply to the valve and prevented it from opening in the time that it should have taken.
And then it goes kaboom.
The whole bottom half of the rocket had to get redone after that, and that was super disheartening.
I refused to look at the camera afterwards because I knew my engine was screwed up.
And it sucked in the moment. I remember in test cell 3, we're all standing there after the detonation, and it was just silence. Like, it was the loudest thing you've ever heard to the quietest you've ever heard.
Honestly, the failures kind of united us as a team, and it was really relieving to see how the whole team handled failure. We didn't see it as like game over. All of us kind of looked at each other, thought about what we needed to do next to fix the problem, and we worked the problem instead of getting stuck, like wallowing in our sadness after seeing the thing nuke itself on the test stand.
The next day, we picked ourselves back up, and I said, Professor Garrick, I have drawings for you. We need to make another injector. And he was like, shouldn't you be crying right now? And I'm like, I don't have time to cry right now, bro.
That's why I think the team was so great, because we bounded back from that the next semester, and in a year we got the rocket flying.
It was kind of devastating, but like from that test, we took a step back, we took a break, we relaxed for like a day, and then we got back to it. The week leading up to FAR was crazy. It was all-nighters for most of it. It was like the few weeks leading up to that too. We prioritized our classes as much as we could, but we were getting ready to go out. We left pretty early. Nice drive over there. We got there, it was very dark once we got there. FAR road's dirt. It's windy, it's bumpy.
We did testing the day before, just outside of FAR, and we had our whole setup with our trailer and The rocket was inside the trailer. We're doing our leak checks there.
The deployment tests that we did right before the launch were really satisfying because it did what it was supposed to for the first time after like fighting with it for a couple months. So I'd say that one was the most rewarding test.
The best way I can describe the feeling of launch day, or the atmosphere of launch day, it was really, oh, finally it's here.
It was kind of surreal. All of us we'd tested the rocket for almost a year.
It was crazy. And I would say it started the day before.
Very excited that the day had finally come and that it was officially game day, but then we were all nervous because obviously we'd never flown the vehicle before, and none of us had ever flown a vehicle before. So
we were all really excited and all just had our heads down because there was still a lot of work to do, and we wanted to ensure that everything was happening properly. We wanted to ensure we didn't have any go fever and launching a rocket that should not be launched.
I mean, this team had been working for 2 years, so insanely dedicated and then also very well supported. Like, we had as many people we could from the club out there. It was a great environment of everybody's hands are working on something, everybody wants it to go.
The atmosphere was go, go, go. We wanted to launch that day, or that weekend. We only really had a few hours of an actual launch window, and we wanted to hit it.
we had lots of issues the day of with getting the vehicle like fully integrated to the rail. So the team worked really, really hard to get that closed out, and I think we got that closed out around 12:30. And so we stepped into actual ops around, like, we lifted it up, stepped into actual ops around 1 o'clock. And we were like, okay, we gotta crank. We've done this literally a million times. Like, this is just another day at the test cell kind of thing was how we were trying to keep the mentality. It was just another day at the test cell. Like, we're doing what we know how to do. And the team excelled at that. I was very proud of them.
The closer you make your test day to your launch day, it will intrinsically have a lot of the testing that real flight will encounter, or launch day procedures will encounter.
Got the rocket vertical through fuel fill with a couple minor difficulties.
Stepped into LOX load and gas load. It was getting more and more real by the second, to say the least.
In kind of the 5 to 10 minutes leading up to it, when we were going through our QD disconnects and final vehicle preparations, there was an issue that we encountered. There was a possibility of a trapped liquid oxygen pressure in some ground side systems that I was really worried about. And so I was really keeping that trap pressure in mind and accidentally drained about a quarter of the liquid oxygen tank out of the vehicle, which ended up saving us, but would have hurt us in the actual total launch altitude.
It was standing in the control room, just behind Miles, watching the vehicle on the rail.
The go no goes went around.
We went through each responsible engineer and got the go from everybody.
Fluids is go. Everyone was go.
Flight control, all systems are go for launch.
And I was sitting there as flight controller, trying to think of any possible reason not to launch the vehicle.
Just made everyone think for a second, like, is my system actually go?
It was really hard for me to hit the launch button. Olivia Wood, who is our team lead, she was just telling me, everything's good, like, press the launch button, just let the rocket take off.
We started into auto sequence start. So Miles pressed the button to start the countdown sequence, and Derek was over his shoulder. I was staring at the data on my screen. I was calling the countdown. 9, 8, 7, 6, 5. Ignition happens. I call out ignition. Ignition. One of the red team members who called out igniter. And then I looked up from my computer out the window.
You never know what's going to happen when you launch a rocket. 1,000 things can go wrong. We try to prepare for all of those.
But successfully, we left the rail. We left the rail way slower than we wanted to.
And so kind of from the control room, looking at the vehicle, as soon as it left the rail, you could see it slightly pitch over.
And I remember it like pitching over as soon as it gets off the launch rail, and I could like feel everybody like tense up. Like it was, you could just feel it. Nobody said anything.
I don't know if I didn't want to believe it, but I definitely kind of went, no, something's definitely not right here. But as soon as it leaves the rail, kind of goes out of view of our control room, it was a lot of anticipation of what did I see correctly, and then you kind of walk outside and you look up and see the rocket is more pitched over and almost going sideways. It's a really bad kind of pit in the stomach feeling.
We were anticipating what kind of failures we could see, and the one that we saw on the flight was the worst case scenario.
The deployment that happened at 21,000 feet, going about Mach 0.5, it still worked beautifully. The whole rocket stayed intact and came down in one piece, and the rocket was spotted.
I was manning the telemega, so I was basically pointing an antenna at the rocket the whole time, trying to track it to make sure we get it back.
So even with the odds stacked super against us, the parachute still came out and the rocket stayed together. Would consider it a success for the recovery system. Would have been nice to get the electronics back. I don't think any of us were able to predict that the all thread keeping the avionics sled on, or like even that the avionics bay would fly back, hit the fins and get destroyed that way. That was not something that any of us anticipated.
We had, I think, 2 GPS pings from only one of our trackers.
A pretty good bearing on where it was coming down, so we were able to like very quickly, very calmly and very precisely go from launch, hop in the back of Olivia's truck and get out there as fast as we could.
And it still was phenomenally successful. We recovered the rocket, we made thrust, we made a successful flight vehicle. But I think there was, a big round of mixed feelings, especially.
It's like such a mixture of like sadness, but also excitement because it launched. It was crazy. But our main goal at that point was like make sure we see it and make sure we find it. So like that was what everybody was focused on for sure.
And we succeeded in terms of recovery. We got the rocket back.
Deneb 2 taught me so much about working with a team, the importance of setting deadlines and properly communicating your progress towards that deadline, and how you are going to hit that deadline or you think you're going to miss it and need support from your team.
I think it impacted me extremely heavily in the hands-on aspect. Like in school, you're going to get a lot of experience with your classes, the theoretical math, but the rocket's going to show you the real reality of what you're working on, what you're working towards.
It taught me how to work hard, that's for sure. It also made me feel like the work that I did really was directly affecting what I was working on.
It really made me a better engineer because it helped me get better at handling failure and seeing the whole team. Like I said before, we were all so united in every failure that we had, and that skill is super valuable in engineering.
It taught me a lot about intuition. It fed my intuition. As an engineer, I'm able to apply it to my job today.
I think it's the people that affected me the most. So it was just amazing to be among all these people way older than I am, way more knowledgeable, way more experienced. and learning from them, it really kickstarted me as an engineer. And
It didn't just impact us as a team, it really made us a team. You grow a really close connection to people who day in and day out are working towards the same goal. So you have this group of people that are really driven towards the exact same goal and have as much drive as you do to reach that goal. So everybody comes together and works their hardest to actually reach that goal.
I think it helped a lot with new members, especially because we were testing basically every weekend.
I was just taking a walk around campus during orientation week, and I hear this loud bang, made my way slowly over there into the blockhouse. And I was like, hey guys. And they're just like, oh, hey, oh my gosh, I'm so sorry. This is the only time we will ever turn someone away, but we just detonated part of the rocket. Please come back tomorrow. And I was like, okay, got it. See you guys. Came back tomorrow, totally integrated with the team.
So in that regard, I think it helped people get more exposure to liquid rocketry.
It allowed me to be a part of this incredible team literally before I had taken any classes at the school.
What I've heard and from what I've seen, Deneb 2 did not go quite as the team had wanted it to. Given that, would you go back to that morning and do the launch over again?
Absolutely.
I definitely would.
Absolutely.
Yeah, absolutely.
Oh, yeah.
I would go back to that launch day and experience it again just as it was.
Absolutely, I would go back and do that all over again.
That flight was a success.
We knew some of the flaws that it had as an overall architecture, but everything about that vehicle was as good as it could have possibly been in order to hit our targets.
And it launched it on our first try, which is kind of unheard of in collegiate rocketry.
If I knew it was gonna happen, I would definitely try to fix it before we went out there. But I mean, they are very fixable problems. It's always the simple things that you overlook.
Like, it had some things not go perfect, but I would still consider it a success. We met our main objectives by recovering that rocket. Didn't go as high as we wanted, didn't go quite as fast as we wanted, but went a heck of a lot faster sideways than we wanted.
With all things considered, I think launching on that day was the correct call.
Even with knowing how unexpected it went, simply because of the people that were around me and just the experience of being able to just see your work come to completion.
So I still, knowing everything I know now, I still would have launched.
I would absolutely go back to that day and launch the vehicle again.
We'd spent 2 years working on this thing. Without a doubt in my mind, if I were that close to launching, yeah, I'd push that button.
It is more fulfilling to see fruits of your labor come to completion in an unexpected way than it would be to leave them on the table and walk away and say, this could have been done.
It's just, it's important to take the learnings that we've gotten from this vehicle and go into our next vehicle and really properly flesh out the architecture that vehicle is going to have to ensure as good of performance as we can have on launch day from the start.